Everyone, my name is Master Ford, as you have known from Science Mastery Center. Sorry it took a long while before I released a video on the calculation of electrical energy and power, because in the last class, I already promised that I'm going to be solving some questions after I discuss electrical energy and power. I give the definition, then I also give the formula, and then I promised that I'm going to be releasing video on some calculations. So it took a long while. If you have not joined our platform, Science Mastery Center, please do well to join. Time is going. Your jam is fast approaching. So let's dive into what we have for today. For more inquiry, don't forget, for more inquiry, you can message me on 081-601-28268. So what I have before us today is a typical wire questions on electrical energy and power. So let's dive into the screen and see what we can do about it. Now, they said a heating coil has a resistance of 20 ohm and is connected across a 240 volt main supply. Find A, the current through the coil, B, the power consumed, and C, the energy used in 15 minutes. This is a typical wire questions. You don't need to panic at all. Just calm down. As I'm going to take you through these questions now, we are going to solve it. You see how simple this question is. So the first thing you do, let me divide this board so we can have a space for solution. Now you write your solution here. Now the first question says that the current flowing through the coil. Remember when I was doing derivation from your Ohm's law, V equals what? IR. Is that not? Abi? So from here, I can find the current to be what? I can find the current to be I equals what? V over what? Over R. That's the formula that I'm going to use. All right. So your I here now becomes what? Now, what's my V? My V is 240. This question is very simple. Over what's my R? My R is what? 20 volts. So this can cancel this. Your I is what? 12 ampere. So I've gotten for A. Now B. B says that the power consumed, remember your P is what? I square R. Okay, so P becomes, what's my I? That's 12 square times, what's my R? My R is 20. So your P in this place can become what? 144 times 20. Therefore, power in this place can become what? 2,800 watts. Okay, so the third question says that the energy used in 15 minutes. Energy used in 15 minutes. So we just come here. E equals what? IVT. Because of the time. Remember, your time is 15 minutes, so convert that to seconds. Times what? Times 60. Okay. So your E becomes what? What's my I? My I remains 12 times, what's the voltage? Your voltage is 240. Then your T is what? 15 times what? Times 60. So your E becomes what? 2.592 times 10 raised to the power of 6. As simple as that. Okay, so this is a typical WAEC question. So let's solve. They said three resistors of 4 ohm, 6 ohm, and 12 ohm are connected in parallel across a 12 voltage battery. Find the total current to the power supplied by the battery. So let's solve. Solution. Remember that these resistors, they are connected in parallel. And when you talk about parallel connection, their type of connection is always connected with side by side. First and foremost, you have to first look for the total effective what? Resistor. So how do we do that? Since it's a parallel connection, we have 1 over RT equals what? 1 over R1 plus 1 over R2 plus what? 1 over R3. So your 1 over RT becomes what? 1 over 4 plus 1 over 6 plus 1 over 12. The LCM of 4, 6, and 12 is what? That should be 24. So 4 in 24, that is what? 6 plus 4 plus 12 in 24, that's 2. Okay? 1 over RT. All right, 1 over RT becomes what? 6 plus 4, 10 plus 2, 12. That's 12 over 24. 12 here 1, 12 here 2. When you cross multiply, your RT here should be what? Should be 2 ohm. Is that not? Now, we are not done because they say we should look for the total current. The total current is what? From your Ohm's law, V equals IR. What's my V? Your V is 12. R is what you are looking for, times 2. Divide both sides by 2. So your I becomes what? 2 here 1, 2 here 6. So your I is what? 6 ampere. All right. The second one, the resistance, that was 2. This will give you what? 36 times 2. That's what? 72 watts. That's the answer. Okay, so this is number 3 question. Remember, we are looking at typical WAEC question. So let's solve this together. Let's solve this together. They said a 12V motor takes a current of 4 ampere full stop. It lifts a 15 Newton load through 5 meters in 6 seconds. Calculate 1, the electrical energy supply, that's the energy in, okay? The useful energy output, all right? Third, efficiency. So let's solve. Solution. Now, one of the things I used to tell people, especially when it comes to solving of physics, is that first and foremost, write out your parameters, because your parameters will give you the insight of what you are asked to calculate. Your parameters will give you insight of the formula to use, all right? So let's go. Our voltage is what? Is 12. Write it out. Your current I is 4 ampere. Then your force, we have a force of what? 15 Newton in this place. Then the distance, your distance is what? 5 meters, and your T is 6 seconds. A lot of students can get this confused because of all of these parameters, and they'll be like, what kind of formula am I going to use? So just follow closely, and I'm going to be solving this now. Electrical energy supplied in. Your E is what? IVT. Use IVT. Your E becomes, what's my I? 4 times 12 times the time. You don't need to convert this again because this is already in seconds, so you don't just leave it like that. Supposing this time is a minute, you convert it to seconds, but since it is in seconds, just leave it like that. So your E becomes what? 4 times 12, that's 48 times 6. So your E becomes what? 48 times 6. 8 times 6 is 48. 48, right? 8 carry 4. That's 24. 24 plus 4, 28. So your electric is 288. 288 joule. Now the second one, they said the useful energy output. Energy output, remember energy is what? Force times distance. So your energy becomes what? Just write this as out, write this as in. In, because it's the energy supplied. In, out, the energy output, the useful energy output. So what's my force? That's 15 times, what's the distance? That's 5. This should give us 75 what? Joule. All right, now the efficiency. How do we calculate efficiency? Efficiency is what? Energy out over energy in times 100%. So your efficiency becomes what? 75 over 288 times. So your efficiency is what? 26%. Thank you.